Well, hello again. I thought today we would do a video on semiconductor and component testers. I've got 3 of them here. Each one of these has some unique features which we will go through. Got a bunch of components lined up here: voltage regulators, Darlington transistors, SCRs, JFETs, Triacs, MOSFETs, Igbt, etc, etc. I also have a little tray here of other components that we can look at, and this will probably going to be the last lab-based video that I'm doing with equipment. Next we're going to do some projects which will be a little bit more interesting and probably more fun. I do have more lab equipment than what I have covered in my previous videos. However, these are kind of specialized, and as we do projects and use the equipment, you'll see it being used, and then we can discuss it then, what the thing is used for and so on. So let's have a look at these multifunction testers, component testers, and discuss each one and in a little bit more detail. Okay, the first one we'll look at is this little one here. This is probably the first one I bought, I think, if I remember correctly. You'll see these things floating around the internet: AliExpress, Banggood, Amazon, and so on. They all look alike. You will recognize them. Some have a different color, and they might have a different lettering on them and so on, but inside they're all the same. This particular one is actually powered by a lithium-ion battery inside. It has a charge port over here. It'll LED to show when it's charging and so on. One thing that wasn't so good about this thing was that it has a start button, which obviously it has a background current that it uses in order to scan this button, because you push the button and then it will turn on, and if you leave it laying around for a week and a half, the battery would be empty, because it has a quiescent current there. So I put a little switch on the top here that actually cuts the battery off. It's as simple as that. So that doesn't happen now. I've charged this one quite a while ago, and when I turn it on, you'll see it'll say something like 4 volts. See, still got 4 volts in it. There's nothing connected to it, so it says damaged or unknown part. If you plug something into it, let's have a look. What about a little JFET here? And you put a start. It recognizes that that's an N-channel JFET, and it gives you a little bit of information about it, where the gate, drain, and source is, the drain current, and the gate voltage. Not a great deal of information, but enough to identify the component. This thing also has actually a unique feature which I've used in the past and found useful. It's got a little infrared pickup there, and if you take a little remote control, like for instance this one here, that you can press start, and then you can aim it at that, and it will come back with the 2 codes that in general that these remote controls output. There is a user code and a data code. I've used it in the past. I had some remote controls, 2 remote controls, and they were sending the same data code, and they were interfering with each other, so I was able to find out what that was all about. And if you are making a project with an infrared decoder on it, then you can actually test it and so on to see if it's what codes. Anyway, that's sort of unique to this one. And next we have this guy here, which also is able to test supposedly the ESR of capacitors, and there's a little table on the back. But I found it to be not very accurate, and I have another meter that tests ESR, and that so I never use it for that purpose. But what is interesting about this one is that you can plug leads into their normal little leads like you will find on a multimeter or something, but I've got shorter ones. You can plug components into these sockets over here. This is for discharging capacitors, but what's unique about this one and why I use this one is this section here. You can put components on there that are the surface mount components, and over here for instance I've got a tiny little transistor, and you would be able to at least I think it's a transistor, got 3 legs on it, you can't tell nowadays. You can lay it down on that SMD devices, that's what I'm saying. You can lay it down on the thing there, you just put a little bit of pressure on it like that, and then you push the button and it'll tell you what it is. Now we will be trying that later on and seeing how that works. So that's what I use this one for. And then we have the expensive one, which is actually made in England and not is not made in China. And because of that, unlike the Chinese ones, it actually comes with a it came with software which is on this little flash drive, and it came with a proper manual, which is nice for a change, because the Chinese stuff never does. So it could do diodes. This one only does semiconductors, not capacitors and things. Zener diodes, diode networks. That's what I'm saying. Some of the 3-legged components actually have 2 diodes in it, so you can't really tell. That little thing I just had there, but it may or may not be a transistor. LEDs, double LEDs, triple-legged LEDs, BJTs, and special this is talking about how they measure the current gain and the base emitter voltage drop and stuff. Collector leakage current, Darlington transistors. It will recognize all of these things. Freewheeling diodes in some transistors. Digital transistors. These are special transistors that respond to like 3.3 volts or 5 volts for logic value, so you don't have to put a little resistor network there. Enhancement mode MOSFETs, depletion mode MOSFETs, enhancement mode IGBTs. We've got one of those laying there, we're going to test it out. Depletion mode IGBTs, junction FETs, JFETs, triristors, SCIs and triacs, some here, we're going to try that. Voltage regulators, that's also handy, but the only limitation is it can't do anything more than 8 volts, which is a little bit disappointing. We will see that later on. I got a 12 volt one there and it doesn't know what to do with it. Then there is some PC software. We will go through that, which is very, very useful indeed. And then there is some stuff in there about how to analyze the components and so on. So this one here, if it wasn't for the fact that you can plug it into a computer and see all the stuff on the screen, the little display on it is rather pitiful. I just plugged a Zener Diode in there, and it tells me that it is a 6-volt one, and it does have a lot of information, this thing, but you have to push the scroll button. And it'll scroll through the information. If you put a transistor in there, there's quite a bit of information, but it's a bit of a pain in the neck, and that little screen is you know, it's just a little black and white LCD. I wish they would make one of these with a bigger screen on it that had color graphics on it and stuff like the Chinese do. But then on the other hand, this one is much more reliable and more accurate than the Chinese ones are in any case. So, and you can hook it up to the computer, so that's a good thing. So we're gonna put these things through their paces, and I've got a bunch of components laying on the desk here, and that is what we're going to be doing next. Okay, finally, this tiny little component is an Npn transistor. Shows you base emitter collector, beta is 120, and forward voltage 673 millivolts. So it's a silicon transistor. You can see it can be a little bit tricky to line those tiny little legs up with those pads, but it does work. And it is what I use this thing for, is to test those little SMD components, because you'd have to solder them down, otherwise it would be rather undesirable. Okay, so I connected up this Darlington transistor here, and it has recognized it, an NPN Darlington BJT, and on the little screen here you can push this button and get more and more information about it. But as I said, it has computer software, and over there you can get all the information on the screen of the computer, which is much more convenient. Tells you the leads, you know, the red, green and blue. Red is the base, green is collector, blue is the emitter. It does have a diode in there, protection diode. It has recognized that, which is good to know. And it has a current gain of 104, voltage base to emitter 1.225 volts at 5 milliamps, VCE saturation 0.63 volts, and so on. No leakage, and it has protection diode. And then it has a bunch of information which you can scroll through, and you can read about how they came up with the measurements and so on, which is good to know. So that's one of the things I like about this thing. It's quite unique that it has that feature, and you'll see some more features in a minute. Now, if we connect the same component up to some of these other ones, we can see what they do. That's the same Darlington transistor. And it doesn't actually tell you that it is a Darlington transistor. On this one, it's coming up with a slightly different HFE, the gain, but it did recognize there is a diode between the collector and the emitter, but it didn't tell me that this is a Darlington transistor. But it was still, the information was still somewhat valid, so not quite as detailed. And that's all you get, is just two measurements. On this one I should be able to plug this in over here. And this one is even worse. It recognized that it is a transistor, but it is only, didn't even recognize that it had the diode in it. So that is not very helpful in that respect. So yeah, this one, the DCA Pro, you know, it is much more advanced than these Chinese things. Alright, well, since we've got this one out here, it's also annoying that this one turns off even if it's plugged into external power. Alright, well, so what do we got? We got an SCR over here. I wonder if it can recognize that. Yes, it does. It's a thyristor, and that is correct. Okay, score for that one. Try this one out. Now here you see the legs don't go into the socket, they're too wide, and I don't want to force it, so I will have to use these little clips. Two and three. Okay, got them connected. So now we can plug in these little leads. 1, 2, and 3. Yes, thyristor. Okay. Very good then. All of them could recognize that, but now let's plug it in here and see if it gives us some some extra information. This one only has lead, so you've got to connect it, test it. Thyristor. So it gives you a lot more information about it. And of course, if we go to the computer, we have how many the latch and hold current, the on the gate voltage 0.7474 volts, and so on. And again, there is a little spiel here on how they test those things and what that means. VK on, VGK are the forward junction voltages when the SCR is on, and so on. Very helpful. Okay. As I said, I seldomly use the little display on this thing, except sometimes I might grab it and quickly plug in a component and test it. It does also have an internal battery as well, so you don't necessarily have to plug it in, but okay, what else do we have? Well, since we are on thyristors, let's plug in a tiny little triac on this one. I think it's a triac. Yep, recognizes that this is a little triac. Wait, plug it in here. Yep, triac. It says UF 0.97 volts. What did it say voltage on this one? Point 0.919 volts, 990 millivolts. A little bit different, but not, I guess, not significantly different. Okay. Okay, it's a triac. But let's have a look at it straight on the computer. Well, not giving us any information about it. Anyway, I guess just identifying it that it's a good triac is good enough. Now, this is a Zener Diode. Okay, Zener Diode. It's obviously a 3.3 volt Zener Diode, but it's only returning 3.213 volts according to this thing. And the green is indeed the cathode. Yep, that's correct. No, I don't know. I've got it connected between 1 and 3, and it says diode 131. I think there is a little bit of confusion there on this one. I think it is getting very confused. It's gone into setup mode. Let's unplug it. I don't know. It's telling us that the forward voltage is 3.12 volts. I mean, it's not telling us it's a Zener. I think that's a failure on that one, as far as I'm concerned. How extraordinary. Two diodes. It doesn't recognize that it is. Also doesn't recognize it's a Zener diode. Interesting. What? So neither one of those cheap Chinese testers can actually tell you that it's a Zener. I mean, it thinks that this is two diodes. It's a Zener diode. What about a bigger one here with a higher voltage? I think I'll have to hook these up. I desoldered this from somewhere and it's got a big blob of solder on one of the legs and it won't. Alright, I've got a big Zener diode here. Will it be able to test it? No. It thinks it's an ordinary diode. Okay. Failure. Let me see what this one does. I'll have to use some leads because I salvaged this out of an old circuit. It's got a big blob of solder on there, so no. Okay. Try this one. Yep, it is able to come back accurately that it is a Zener diode. The other two failed. So to show you, those cheap Chinese things, they do have their limitations. But then this one probably cost 4 times as much. And tells me that it's a 6-volt Zener diode, which is exactly what it is. And the other two thought it was an ordinary diode. I guess because it is a more powerful one, it got confused. It's a chunky Zener diode with more power. Now, voltage regulators. This is a, what is it? I've got to shed some light on it. Can you see it? Well, I can see it. It is it's really hard, you know, it's a 7806, is it? I think so. Okay. voltage regulator. Okay, it's a 6-volt voltage regulator, yes indeed. It was an LM0687806 or something like that. I don't think that these guys do voltage regulators as far as I know. No, you put a voltage regulator in there that just say no unknown or damaged part. They can't deal with it. Now I have a little 12-volt regulator here, and even the DCA Pro can't read this one because its instructions clearly say it can only handle up to 8 volts. So I can hook it up, but you will see it won't. See, no component detected, it can't handle that. Alright. So what about LEDs? This is a yellow one. LED, forward voltage 1.942 volts. That's what it says. It just says diode, 1.95 volts. Well, the forward voltage is accurate. Yep, same. Doesn't know that it's an LED, but it does know it's a diode. Here I've got some this is a photo transistor, probably an infrared one. I wonder what it'll say that what this is. No, can't handle that either. What about one? Part unknown or damaged since got 6. Not sure what 6 means. Anyway, I didn't think that it will be able to handle that. Oh, an Igbt. This is a big Igbt 50JR22 Toshiba. These guys are often used in switch mode power supplies, but more often in control circuits for motors. Actually has a little MOSFET on the input. Oh, it can recognize it clearly. Enhancement mode Igbt did it quickly too. And also has a body diode in there, which is similar to what MOSFETs have. I am not sure if these guys here can actually test these. At best, I think it will probably think it's a MOSFET or something, or faulty MOSFET. I don't know. Okay, I hooked it up to these little leads here, 1, 2, and 3. No, now stand corrected. This one knows it's an N-channel enhancement Igbt. So it can handle it. Actually, while I got it on those leads, rather than reconnecting it to these leads here, I think I can plug those into these little sockets. It also is able to handle an Igbt. Insulated gate bipolar transistor, Igbt. Okay, well, I wasn't sure if it was able to do that. Here's an interesting thing. This is a Uni Junction Transistor. That's the symbol for it. These things were very popular in the 70s and maybe still in the 80s, I'm not sure. They were often used to make oscillators. And it's things that are two diodes in there with different forward voltages. And I do not believe that the DCA Pro knows about it either. They're hardly used anymore. I'm not even sure if you can still buy them. This is marked as a what is it now? A 2N4891. 2N4891. I did still find a data sheet for it, an old archived one. Not sure why they fell out of favor. They were quite popular in the 70s for. Yeah, see, it can't handle it, no component detected. And I don't think this one can either. I doubt that this one knows what it is. But we do the same thing, coming back with two diodes. Yeah, so Uni Junction Transistors. This is a PN. They just have just a P and N junction, but it's done in such a way, I think, that it avalanches after a certain voltage, and hence that you can get a you can use it as a for an oscillator. All right, so here we've got a JFET. And it's an N-channel one. Yeah, no problems. They can all handle those. I'm not gonna bother to N-channel JFET. Here is an old germanium transistor, 2SB370. Germanium transistors have a much slower reverse voltage, but they always have leakage. BJT PNP doesn't actually tell you that it is a germanium one, other than you might be able to work it out from that VBE value. It should tell you that it's germanium. This one doesn't tell you either. It tells you that it's a transistor. But when I plug it into here, this one should tell me a little bit more about it. Yeah, see, this one does tell you that it's a germanium BJT. And you see how it has reverse leakage, 1.606 milliamps. That's typical for germanium transistors. They have a same with germanium diodes as well. They have reverse leakage. Which you have to take into account when you are designing circuits with these things. Not that we still use them. Germanium diodes maybe occasionally if you want a lower voltage, but usually Schottky diodes are used for that purpose. Okay, let's have a look. What else do we have? I'm going to get a stock standard transistor, and we'll do some curve tracing on it. Okay, so I've got a 2N2222, whatever it's called, transistor here, connected to the Atlas DCA Pro, and I pressed the test button, and we got this information, HFE 253 at 5 milliamps collector current, voltage base and emitter 0.748 volts, and the VCE collected to emitter saturation voltage when it's fully turned on, 0.012 volts with a base current of 1 milliamp. No leakage. And then I did a collector current versus collector to emitter voltage graph, and as you can see, when you move the cursor over it, it'll actually tell you the voltage versus how many milliamps accurately. So this is the kind of graph that you use in order to select an operating mode. And of course you can see from here that especially down here at that the lower ones here are very linear, so that you can pick a good range there for amplification. You're building a little amplifier that is going to be reasonably linear. Here we got DC gain versus collector to emitter voltage, and you can see that's pretty much stable over the whole range from 0 to 12 volts. And here we have gain versus collector to emitter voltage. Now I only did 2 traces here. We can do more. We can do let's say 5. And as you can see, it'll do, this is probably going to be the 2 volt trace. Oh no, it still says 1 volt. Oh, you know what? I think this is left over from another transistor. Let me stop this and show you how that works. And then you go to graph, and you can say delete and all traces. Okay, and let's start it again. So this was at a 1 volt collector to emitter voltage. This is at 3.25 volts. I told it to go from 1 to 10 volts. So it's going to divide it by 5. So 5.5 volts. 7.5 volts and 10 volts. So that is what that is. Here it is collector current versus base to emitter current voltage rather. Again, fairly stable over the whole range. And here again, this is the collector current versus the base current. One is in microamps, one is in milliamps. And as you can see that you'll get more output when you put more input. So this one here is usually the more used one if you want to check what a transistor how a transistor behaves, and you can use this information to select your operating voltages for your if you're building a little amplifier, common emitter amplifier, something like that. Alright, so that is what you can do with the DCA Pro. Okay, now let's have a look. These two guys here claim to be able to do inductors, resistors, and capacitors. So let's have a look how they respond to those kind of components. I've got a small capacitor here, It's I don't know if I can read it in the, it's not that light here. Anyway, let's plug it in. Well, first of all, let's hook it up to the proper LCR meter that we know is accurate. And we're going to be selecting capacitance, and let's select ESR since now we know that ESR is actually the resistive component of the impedance. And I'll press hold, and then we can compare it to whatever these guys. Let's try this one first. You'll start to see this black one here is not very good. It's not very accurate, and it has some problems with displaying resistances. Often it comes back with 0.00 when there should be something there. According to this, that is 220 picofarads, and well, that's, I guess, not too bad. It's a little bit low. It says 229 on the LCR meter, so we'll let it get away with that. 217 picofarads. So this one is actually out even a little bit more. So, but still, it's close enough to show that it is a capacitor and it's working. Here we got a bigger one. Now these are those green capacitors. Now this one is 430.8 nanofarads, ESR 5.8 ohms. Okay, now we've got to actually put it on here and see what the LCR meter says. 445 and 1.6 ohms. Now the ESR value, of course, is going to change with frequency. This might give us a clue what frequency these things are actually operating under. Let's push this again, because it doesn't tell you. See, it claims that the ESR is 5.9 ohms, 430 nanofarads, 5.9 ohms. So if we put this in here and we change the frequency, so we're getting the impression here that it's somewhere between 120 and 200 hertz in order to get she's at 7 on 120, and it's 4 on 200. So it's somewhere between 120 and 200 hertz. Probably it is testing the components on. And there's no different serial parallel. Let's hold this for a sec. And this one here is going to be different. This one says 438 with ESR 0.56 and 438. It's a little bit lower than the LCR meter, but 0.56 ohms. I guess one could put an oscilloscope in there and see what it is like, but I'm just demonstrating how that ESR value doesn't mean much unless you know the frequency it's operating on. 10 kilohertz. Okay, so it seems to be indicating that we are dealing with 15 kilohertz on this one as a test frequency, which is high if you're doing electrolytic capacitors. So, but still they both are, they're reading low, but you know, you don't expect too much from these things, so it's probably not too bad. At least you know that the capacitor is kind of in that range. Now let's try some electrolytic capacitors here, and in order to do those we have to put this thing in not DCR, one here in ECA mode, so it now has a bias voltage, which is what an electrolytic needs. It's put the frequency on 1 kilohertz, but which will be appropriate for a little one like this. This is a tiny little electrolytic. This one is actually marked at 10 microfarads at 50 volts. So let's have a look now. And so what is the if we go down in you see at electrolytics, they are not good at higher frequencies. If I go to 120 hertz, if this was used in a low frequency, it actually has more capacitance. It's supposed to be 10, and if I go to 100 hertz, it gets close to 10. But if this was a little capacitor used in an audio amplifier, then 1 kilohertz would be appropriate, and we're only getting 8.8 microfarads. Let's put this on hold, and let's have a look what these guys are going to do. I'm going to discharge each one just in case. Now these testers are not marked, they have a positive or a negative input. So this one is saying 10.09 microfarads, ESR 1.3. So it is obviously, again, reflecting that it is using a reasonably low frequency, but 10.08 microfarads at 1.3. That's almost identical to the other one. So in order to get an ESR of 1.3 ohms, I wonder what frequency you would have to run it on this one with. It's like 8 kilohertz. Before we seem to think it was 15 kilohertz. Yeah, could be. It's pretty close. Somewhere between 8 and 15 kilohertz would give you that reading. However, it seems to be thinking that it's 10 microfarads, 200 hertz. It's giving me 9.5. Anyway, that's what I get with that one. This one here is 1000 microfarads, and now these are very cheap Chinese capacitors that I bought in a little box, you know, just for a few dollars, and it just goes to show you. I wanted to show you this. This is, they came out of the same compartment. These things are marked as sunny, and they have 16 volts, 1000 microfarads. So I'm getting 936 microfarads here, which, you know, kind of you would think would be reasonable. Usually 1000 microfarad capacitors have a bit less capacitance. But then this one over here, I got out of the same little container. It actually has 1500, nearly 1600 microfarads. That's quite a range. That's like 50% more. So you've got to be careful with those Chinese capacitors. If you're doing an important project, you better buy some decent ones from a reputable supplier. Okay, 1006 microfarads. Yeah, it's not bad. $975 microfarads. And you see, this is what I'm talking about. If the ESR is supposed to be, you know, 0 point something, it just comes back with 00 on this thing. So that is kind of pretty useless. So I know that this thing, you know, I would never take ESR readings on this thing because I know how inaccurate it is. So at 200 hertz we're at 942 microfarads at 0.13 ohms. So there should have been something there, not 0.00 ohms. It's just incorrect. Oh, let me let's do the other one now. I'll put it on hold so we can see what the right, 1.59. $1.1800 microfarads, way high, and we still got an ESR 00, so that's way out. So remember that this black one here, very inaccurate, and I do use it because it has that SMD component thing. It does tell you whether, if you got a little transistor or something, if it is a transistor or a diode package and so on, and if the transistor is working. But any of the values on this thing, I would not necessarily going to be accurate. Okay, this one's also saying 1.884 microfarads, and but the ESR is actually much closer to what it should be. Anyway, that's so much for capacitors. Now inductors are much harder for these things to recognize. For instance, here we have a let's put this thing now again in in inductance mode. This is a 2.2 microhenry inductor, and set to 15 kilohertz, which should be appropriate for a little inductor like that. You might be running that in a little switch mode power supply or something, even at 400 kilohertz. Anyway, let's leave it there. 2.2 microhenries. And when you put it in these things, you will see that it has exceeded their limit. They will not recognize it as an inductor. They think it's a resistor with 0.06 ohms resistance. And this one does the same. And as I said, there's something wrong with this software. It can't even display the 0.06. It just becomes 00 ohms. So again, there's something with that thing that is not right. Here we have a 4.7 microhenry inductor. It's coming back with 4.645 microhenries. And here this is going to be interesting, because this one here is actually able to recognize it as an inductor, but for some reason it never displays microhenries. It always has millihenries on the display here. A little bit small, I guess. 0.01 mH it says, with a resistance of 0.09. So I guess if you convert this to millihenries, you would end up with what did it say? 0.01. You would end up with 0.04, but it's a 6, it becomes a 5, so it gets bumped up to 1. So yeah, you would end up with as an inaccurate value as 0.01 millihenries. Now this one here still doesn't recognize it as a inductor. It still thinks it's some sort of resistor with very low resistance. So we can say that this one has a better circuit in there to actually recognize an inductor. It comes up earlier at 4.7 microhenries, but it's not able to actually put it on the display as 4.7. It puts it as 0.1 millihenries. So at least you know it's an inductor, but it's not very helpful as if you want to know the exact value. Okay, now we have this is a 1 millihenry inductor. That's what the box set that it came out of, but it's only returning 973 microhenry, so it's a little bit low. Not the reading, but the actual device. But in any case, that's what it is. And if we plug it in here, obviously it is going to recognize it, but let's have a look what it says. This thing gets stuck sometimes, like the display is supposed to go off, but start doesn't work and the display stays on. But since I put my little switch on there, I can actually kill it and put it back on. Yeah, 1.03 millihenries. It's reading higher than, obviously, than what the value is. Now it has a resistance of 38.7. Let's have a look what the actual DC resistance is. 3 ohms. So what did it say? "38 ohms? I don't think so. Where's my little multimeter probe here? I love this thing. I always reach for it instead of for the 3 ohms, just like the LCR meter said. So I don't know where it's got that 38 ohms from. Unless it is giving you the impedance at a very low frequency. In any case, not sure what that's all about. This one here, this one is correct. It says 3 ohms, that's what it is. And 0.90 millihenries. And you know, that's actually what 975. It's reading a little bit low and this one's reading too high. So that gives you a little bit of an indication what the what it does with inductors. There's a limit as to how low it can go. There's probably a limit to how high it can go as well, but we're not going to investigate that today. So that is, what else? Do we have anything else here? No, we just got some capacitors and inductors, so that is what these things do. So be aware of the limitations of this thing. This one is the better one, and if you just only want to just buy one of these things, then obviously this one here would be a better one to get than this one, because this one is not, it's got some bugs in it or something. It's not accurate either. Alright, so that's all I've got for now. I think we'll call it quits, and we're going to do some projects next. One of the things that are coming up is I want to make a little light box, and that can double up as a light for when I'm doing videos and stuff. I've got some LED strips and a little power supply, and we'll see where we go with that. Anyway, look for the next videos, and you might find that a bit more interesting.